Welcome back, everyone. We're doing exercise 4b, equations of parabolas. So today we're just going to be determining the quadratic equations. Basically, all you need to be able to do is find the equation of a quadratic, given that its key features. So when we are given information about a quadratic, we can put it into a particular form. Now, this is the form that we've discussed, which is the general form of a quadratic, but there's other forms that quadratics can look like. So, for example, this form here is its factorized form. And this is the form that we use if we know its two axis intercepts. So its intercepts here would be E and F. Of course, you should never ever forget that A, which is the dilation factor. So just because you know the 2x intercept doesn't mean that you know the full form of it, because we'll always have that A that we need to deal with. In order to find that A, we just need another point. So that's why we talk about one other point needs to be known so that we can substitute that into the equation and rearrange to find A. We also have its turning point form. So if we know its turning point, we can substitute that straight into h and k, and of course we still have that dilation factor of a. If we don't know any special points, so we don't know its axis intercepts and we don't know the turning point, then what we can do is use its general form. And the only way that you can do this is if I know 3 points, because for every unknown, I need a point. So in this case, I have 3 unknowns, A, B, and C. So I need to find 3 points, or have 3 points, and be able to substitute them in order to be able to find the form in that way. So let's start with the examples, which is going to give us, essentially going to be asking us to be able to find the particular equation of each of these. So a parabola has x-intercepts at -3 and -2, and it passes through this particular point here. I'll find the rule. So as soon as I see this, I'm automatically thinking of the x-intercept form. So that's a, x minus b, x minus c. And because I know it's axis intercepts, I can substitute them in right away. Now just make sure that we do change the signs. That's why we have a negative in the general form, so that we change the signs when we put it in. So that's that one. And now to be able to find a, which is the dilation factor, I just need to substitute that point in. So we're going to go -24 equals a, 1 plus 3, 1 plus 2. So 1 plus 3 is 4, 1 plus 2 is 3. 4 times 3 is 12. So when I rearrange that, I get a is equal to -2. So my final equation is going to be -2, x plus 3, and x plus 2. So steps for this one. First thing, determine what information they've given you. So in this case, they've given me the x-intercepts. Ensure you have one other point. I guess that would be step 2. And just substitute it all in. Okay, next one, determine the equation of the given graph. So again, we've got some information here. You have to be really careful. In this case, this is not the turning point. It just happens to be the y-intercept. It's actually very similar to the previous example, so it might be worth for you to pause the video and give it a go yourself. But this time we've been given 2 x-intercepts and we've got another point. So this is not the turning point, it's just another point to substitute in. So exactly the same thing as before. I'm going to go ahead and substitute it straight into the equation. We're going to change the signs around. And then to be able to find a, I'm going to go ahead and sub in this point. So that'll be -4a, 0 plus 5, 0 minus 8. That's 5 times -8, which will be -40. So then when I divide both sides by -40, I'll get 1 over 10. So my equation will be 1 over 10, x plus 5, and x minus 8. That's it. Very similar with your turning point form, or if you had a general form, but all you have to do is grab the key points and substitute them in.